We now discuss the second type of strong authentication method, which is challenge response scheme. In this scheme, Bob the client and Alice the server has to have a shared secret key beforehand. That is a prerequisite of challenge response scheme. Now, when Bob wants to log into the server Alice, he needs to send an ID and the authentication request to Alice. Upon receiving Bob's ID and authentication request, from Bob, Alice needs to compute a non-repeating challenge C. And this challenge is ideally non-repeating because one-time password will be derived from this challenge value. After Alice has generated this value, it will send it to Bob the client. So Bob will have to compute a one-time password value from this challenge. How does it so? He will either encrypt this challenge C using the key K or compute the hash of the C using the key K. In this case, this hash is also known as keyed hash method, just like message authentication code, MAC. The question is, how does Bob know whether to use encryption or hash? Bob knows because this is predefined by the system, by the server system. So depending on the type of server system you are using, whether to use hash or encryption, it is already predefined. So let us look at a concrete example which does use this challenge response scheme, in which the method to use is already predefined. Microsoft Windows remote server system. A client wants to log in to a remote server system. First of all, they must already have a shared secret key beforehand. The client will send a type 1 message containing a set of flags. And these flags will contain information such as the ID of the client and the authentication request, saying that, hey, I want to log in to you. When the server is up and running, it will reply back a type 2 message, which contains a set of flags and the non-repeating challenge, which has a size of 48 bytes. And these flags will contain information such as the availability of the server, whether the server is up and running or not. And if the server is up and running, it will also include the random challenge for the client to compute the one-time password value. So when the client receives this, it will compute a type 3 message, which is basically a response of 48 bytes. And this response is computed by using the shared secret key between client and the server. In the next slide, we will look at how this response value is computed. Just like when we discussed about password hash scheme used in Windows operating system in your local machine, when we are talking about Windows remote server system, they also have two versions, NTLM version 1 and NTLM version 2. Obviously, version 1 is the old one used in the old Windows remote server system, and this is a new one. And I will only explain about how does this NTLM version 1 is computed. And if you have understood how does this work, you should be able to derive how does this NTLM version 2 works on your own. And that is a challenge for you. Now, let me explain about NTLM version 1. So first of all, the server computes a non-repeating challenge C, which has 8 bytes. And then based on that shared secret key, which is denoted here as password PW, that is a shared secret key between you and the server. It computes two values, two hash values to be precise, LM hash and ND hash. How LM hash and ND hashes are computed, we discussed this in the earlier lessons when we talk about password hash schemes used by Windows operating system. That is the same thing. The value is how it computes is the same process. Recall that both LM hash and ND hash has the size of 16 bytes. So after computing the challenge C, the server will take the anti-hash value, which has 16 bytes, and then it will pad or concatenate with 5 bytes of 0. That is to get a value which has a size of 21 bytes, because 16 plus 5 is 21 bytes. Why do we have 21 bytes? Is because we want to split this 21 bytes into 7 bytes each. For example, this is just an example. Assuming that you have 7 bytes, 7 bytes, 7 bytes, in total 21 bytes. You want to split this into 7 bytes each, which this correspond to K1, 7 bytes. The next 7 bytes correspond to K2, and the last 7 bytes correspond to K3. Why do we have these three, K1, K2, and K3? Is because each of the key K is to be used in the DES encryption. So you take the key K1 to encrypt the challenge C using DES encryption method. Similarly, you take K2, the key K2, use it to encrypt the challenge C using DES encryption method. Likewise, you take K3 to encrypt the challenge C in DES. So you will end up with 3 encrypted value. And since C has a size of 8 bytes, the output of each DES encryption will also be 8 bytes, because in the encryption, the size of the input and the size of the output are the same. So you have 8 bytes here, 8 bytes here, 8 bytes here. In total, you have 24 bytes. And each value are just simply concatenated. And these concatenated values of 24 bytes is called R1. And this R1, I repeat, is computed based on the anti-hash value, which is computed from this shared secret key, PW. Now, using the same process, a different 3 keys, K1, K2, K3, we are using the same notation, but know that this will be the different values, because these three set of keys are derived based on now LM hash. Okay. In the next step, the system will take this LM hash value, which also have 16 bytes, concatenate with 5 bytes of 0. Again, it will have the 21 bytes, split into 3, and each 7 bytes will become key to be used in the DES. So the same process is applied. Take the key K, use it to encrypt the challenge C in DES, and take another key K, use it to encrypt the challenge C, and also take the last key K3, use it to encrypt the challenge C, and each encryption will result in 8 bytes. And since you do 3 times, you will end up with 24 bytes. And the concatenation of these 8 bytes each is denoted as R2. So the response is simply a concatenation of R1 and R2. And since both R1 and R2 has 24 bytes each, the size of the response will be 48 bytes. So which is the output of response, which is the size of response, as we discussed earlier in the earlier slide. So that is how response is computed using NTLM version 1. All right. So if you have understood this, if you don't understand, if you didn't understand this, please watch this video again, trying to follow the steps. And after you have understood this, try to derive the response value by using this NTLM version 2 methods. All right. So that is the challenge response scheme, which is actually used in Windows remote server system. And just like before, you don't really need to memorize the steps that are involved, but you need to understand once you see these steps, you need to understand how things work. So for more detail, you can look at this website that I put here. And that's it about challenge response scheme. In the next mini lecture, I will talk about the last type of strong authentication method, which is timestamp scheme. That's it for now. Thank you very much. See you next time.